So today we are going to be talking about surface area of prisms. And what is a prism? A prism is a solid with a cross-sectional area, meaning if I enter on one side, it will just have the same area until the other side. So for example, a rectangle, when we are at the width, the area of the width side, the width and the height, when you check that area and then you walk, it has the same cross-sectional area to the other side, meaning at the bottom it doesn't have corners. That's a prism. Or if we take a cylinder, we find that one of the end is usually circular, so you can go through it to the other end. Or using a pipe, when water enters through a pipe, it comes out through the other end. Inside the pipe, there are no corners, so that's an example of a prism. Now, how do we find the surface area of a prism? Remember, when we were finding the surface area of cuboids in Form 1, we were opening them to nets, and then we were finding the area of all the other areas. So that's how we find the surface area of solids. Now, in prisms, for example, we were given the cuboid here. Now, this our cuboid has a width of 3, a length of 8, and a height of 4. And we know we're dealing with surface area. And in surface area, we must find the area of all the sides. And in a cuboid, two opposite sides are equal. So instead of calculating the surface area of all sides, you can calculate for one side, you multiply by 2 to represent the other side. Then you can calculate for another side, multiply by 2 to get the other side. So now, back to our cuboid, it has a width of 3, a length of 8, and a height of 4. So let's calculate our surface area. So we are going to start with the side of 3 times 4. So 3 times 4 is 12. 12 times 2 is 24. So we have the surface area for 2 sides. We are remaining with how many sides? 4 sides. Now we check the next 2 sides. Then we check the side for 8 times 4. 8 times 4 is 32. 32 times 2 is 64. So we're remaining with how many sides? Again, 2 sides. Remember, we found the area for 4 sides already. So we've taken for one side, we multiplied by 2 to represent the other side. And then we've taken another side, multiplied by 2 to represent the other side. We said in a cuboid, 2 opposite sides are the same. Now, the last side we have 8 times 3. 8 times 3 is 24. 24 times 2 is 48. Now, after that, we have the sides, but we don't have the surface area. So we have to add all the sides. So we take 24 plus 64 plus 48. And when you add this, you're going to get the surface area as 136 centimeters squared. Now, let's look for the surface area of another prism. And you're supposed to find its surface area. And how do we find its surface area? Remember, in surface area, we must look for areas of all sides. And looking at our diagram, how many sides does it have? It has 5 sides, and 2 sides are equal. I said in a cross-sectional area, when you start from this side, you move to the other side without having corners at the middle. So it means when we enter through the first side, our triangular side, and we walk through it, we're going to come out through the other triangular side. So we have 2 triangular sides. So we can start by finding the area of the triangles. And in our diagram, the triangle doesn't have the height. It's a right-angled triangle. And what's the formula for finding the area of a right-angled triangle? It's a half times base times height. But in our diagram, we don't have the height. So you have to look for the height. Remember, we use the Pythagoras theorem. And the Pythagoras theorem states that a squared is equals to b squared plus c squared. So any side can be your A, B, but your C, your hypotenuse now changes everything. But here we're looking for our height. So we have our base as 3, we have our hypotenuse as 5. So how do we get our height? We are going to take our hypotenuse squared minus our base squared, and then we find the square root of everything. So our hypotenuse is 5. So 5 squared minus 3 squared is equals to, when you calculate this, you're going to get 25 minus 9 is equals to 16. So we find the square root of 16, and the square root of 16 is 4. So our height will be 4. And then we find the area of our triangle. And the formula for finding the area of a right angle triangle is a half times base times height. So on our base and our height, we insert our figures, and our base is 3, our height is 4. So a half times 4 times 3 will give us 12. And then after getting 12, we multiply it by 2 to get 24. So we have the both sides. Then now we have 3 remaining sides. And what's interesting about our 3 remaining sides is that they are rectangles. And to find the area of rectangles, we usually use length times width. Now, checking our first rectangle, we're going to take 9 times 5. Its length is 9, its width is 5. 9 times 5 will give us 45. And then on our other rectangle, we're going to have the lower one acting as our base. We're going to have its width is 3, its length is 9. 9 times 3 is 27. And then looking at our diagram, we have a side that is hidden, and this side that is hidden is also a rectangle. So again, how do we find area of a rectangle? Length times width. So on our hidden side, its length is going to be 9. And what is its width? It doesn't have a width, but remember, we looked for the height of the triangle. So this height of a triangle will act as our width. So 9 times 4 will give us 36. Now we have the areas of all the sides, and we want to look for the surface area. So how do we find the surface area? We simply add the area of all the sides. So we're going to add 24 for the triangles, and then for the other rectangles, which are 45, 27, and 36. So adding all this, you're going to get your surface area as 132 centimeters squared. Remember, when you're dealing with surface area, it has to have a squared, a unit squared. Now, we have another prism given here. So how do we find the surface area of our prism? And our prism has a cross-sectional area, and this cross-sectional area is a trapezium. So it's like you're entering through a trapezium and getting out through a trapezium. And how do we find the area of a trapezium? Area of a trapezium is a half times a plus b times height, where a plus b are the sides, the top and the bottom, the opposite sides, the opposite parallel sides of a trapezium. So A and B. And then we have our height. So the formula for finding area of a trapezium is a half times A plus B times our height. Now, looking at our diagram, do we have the A and B, and do we have our height? So we have our A and B as 4 and 10, and we have our height as 7. So we're going to find the area of one trapezium, and then we multiply it by 2 to represent the other side, instead of calculating for one side and then going to the other side to calculate them separately. So we just calculate for one side, we multiply it by 2. So to find the area of that one side, it's going to be a half times our A is 10, our B is 4. So 10 plus 4 is 14, and our height is 7. So a half times 14 times 7, we are going to get our answer, and then we multiply it by 2 to represent the other side. Calculating your areas of your trapezium, you're going to find for one side it's going to be 49, and remember there are 2, so we multiply it by 2 to get 98. Now looking at our diagram, how many sides does it have? It has 1, 2, and then it has the top side 3, the bottom 4, and then 5 and 6. So it has 6 sides. So we found for 2 sides. Now our remaining sides are rectangles, and we know to find the area of a rectangle, it's simply length times width. So we find the areas for each rectangle. So starting with the first one, we're going to look for the top one, and we'll have 4 times 15, and 4 times 15 is 60. Then we have another side, another rectangle, which has the length 10 and the width 15. The length 15 and the width 10. 15 times 10 will give us 150. And then we have the hidden side, and the hidden side has a width of 7 and a length of 15. 7 times 15 will give us 105. Now, there's this side at the front, and we don't have its width. We have its length, but we don't have its width. So how do we find its width? Using our trapeziums, we are going to find the slant side of the trapezium, and this slant side of our trapezium will act as our width. So dividing our trapezium, you're going to find that at the bottom we had 10, at the top we had 4. 10 minus 4 will simply give us 6 for the remaining part. So it's like we are forming a triangle, and then the height will maintain, it will be 7. Using Pythagoras theorem, we are going to find our hypotenuse, and it is this hypotenuse that is going to act as our width. So calculating, we are going to find our hypotenuse as 9.23. So now our width is 9.23 and our length is 15. So 15 times 9.23, you're going to get 138.45. So now we have our 6 sides. Now to get the surface area, we add the area of all sides. So adding 98 plus 138.45 plus 60 plus 150 plus 105. You'll get your answer as 551.45 centimeters squared. Don't forget the units. The units are very important. It is what differentiates calculating area from calculating volume and from calculating perimeter. Let's look at another prism. Now, we're given a statement, so we're supposed to calculate. And the statement reads, calculate the total surface area of a solid cylinder where radius and height are 9 centimeters and 12 centimeters, leaving pi in your answer. So here, you've not been given your value of pi as 3.14 or as 22/7. So instead of replacing the values there, you're just going to use pi as a sign. Now, what's the first thing you do? You're going to draw your cylinder. So after drawing your cylinder, you're going to fill in your values. And here, you've been given your values, your radius and your height. And your radius is 9 centimeters. Your height is 12 centimeters. So how do we find the surface area? When we open our cylinder, we are going to have 2 circles, and then we are going to have a rectangle. So we have a circle, and we have a rectangle. So we are going to find the area of this circle, the area of the bottom circle, and then we find the area of this triangle. And these circles are similar. So we can find the area of one circle and then we multiply it by 2 and then we add it to the area of our rectangle. So to find the surface area of a cylinder, we can use the formula pi r squared times 2. So that's the area of one circle. We multiply it by 2 and then we find the area of our rectangle and then we add them. So beginning, we're going to find the area of the circles, and our circle has a radius of 9. So pi r squared, where there is r, we replace with 9. So we're going to have pi times 9 times 9, which is equals to 81 pi. And then we multiply it by 2. Remember, we have a top circle and a bottom circle. So multiplying it by 2, we are going to get 162 pi. We've been used to use pi, not 22/7. Again, we find the area of our rectangle. And how do we find the area of our rectangle? We don't have the length, but we have our width, and our width we had been given as 12. So how do we find this length? Remember, it was a cylinder. So on opening it, it formed a rectangle. So it means the length is supposed to be the same as circumference, and circumference is pi d. So we look for circumference and we have our pi. What's our d? We are going to check our radius. We multiply it by 2. 9 times 2 will give us 18. So finding the length, it will be pi d. So we have 18 pi. Now, we're looking for the surface area, and surface area entails having the areas of all the sides. So now we're going to add the areas of the circles and the area of our rectangle, and then we find our surface area. So adding them, we're going to find our surface area as 378 pi. So after finding your circumference, it acts as your length. Then area of a rectangle is length times width. So you take your length, you multiply it by your width, and your width was 12. So 18 pi times 12 will give you 216 pi. So you add your 260 pi to your areas of your circles, and then you're going to get your answer as 378 pi. Now, our last example on surface area of prisms, we have this question. It reads, the surface area of a cuboid is 586 centimeters squared. So you have your cuboid in mind, and you know our cuboid is just like a rectangle having 6 rectangles taken together. So for example, the matchbox you use at home, that's an example of a cuboid. So you're told the surface area of a cuboid is 586 centimeters squared. So you pause there and tell yourself a cuboid has 6 faces. So after calculating the areas of these 6 faces and adding them, these people found out that the surface area is 586 centimeters squared. Given that its length and height are 12 centimeters and 7 centimeters respectively, find its breadth. So we have the length, we have the height, we don't have the breadth. So how do we find the breadth? And we have the surface area. So given our cuboid here, we have our length as 12 and our height as 7. So we're looking for the width. And how do we find the width? Remember, it's a cuboid, and multiplying two sides will give, taking one side, multiplying it by the other, it means you've gotten the area for two sides, because in a cuboid, two opposite sides are equal. So you can just have 3 calculations, you multiply them by 2 to get the areas, and then you add everything, you get your surface area. But now in our question, we have the surface area and we have the length and the height. We don't have our breadth. Now remember, when we take the lower part and the upper part, we're going to have our length 12 times a width. So let us give it the letter C. So we don't know what our C is. So calculating this, multiplying it by 2, we're supposed to get 24C. So this is an area of 2 sides. So we leave it at 24C. Then we take another side, look for its area, multiply it by 2. So we take the side 12 times 7. So 12 times 7 will give you 84. 84 times 2 will give you 168. Then we look for the area of the side connecting the height and the width. And remember, we don't have the width, but we have our height as 7. So 7 times C will give us 7C, times 2 will give us 14C. So now we have the areas for our sides. So we have the first one as 24C, the next one as 14C, and the last one as 168. So adding all these, you're supposed to get your surface area as 586 centimeters squared. So we are equating it to 586 centimeters squared. So we're looking for our C. So calculating this, we are going to get 38C. Collecting like terms, we are going to get 38C plus 168 is equals to 586. Now, we're going to get C as 11. So our width is 11. So we've been dealing with surface area of prisms, and we've said a prism is a solid with a cross-sectional area. For example, a pipe. Water enters through one side and comes out through the other side without facing bends inside the pipe. So that's an example of a prism. Or if you're having a room, when you're having the side of the entrance if it's a cuboid, one side, when you enter through one side, you come out through the other side. You don't face corners. So for example, if it's a living room and it's just a cuboid, there are no corners. So that's an example of a prism. So on our next lesson, we're going to look for surface area of a pyramid. I've been your teacher, Teacher Whitney.